Hi, maths students. I hope you're all well. And today we're going to learn about truncation and error intervals. Now, to truncate means to shorten or to cut something. And in the context of mathematics, that's usually used when we are dealing with numbers such as decimals. So for instance, 6.38 truncated to one decimal place will be 6.3. Now, usually, if it had said rounded to one decimal place, well, this would round to 6.4. But the difference with truncation is that we cut every digit after the first decimal place. So it doesn't matter if the second digit is a 1, a 2, a 3, or a 9, or in this case, an 8. We simply look at this first decimal place and ignore all other decimals. So if we had something like 6.3999, again, this truncated to one decimal place would be 6.3 because we need to cut or ignore all the other digits after the first decimal. Likewise, in the second example, so 7.235 truncated to two decimal places will be 7.23 because we ignore the second sorry, I should say we ignore the third digit. And once again, if we were rounding to one decimal place, to two decimal places, this would round to 7.24. But in the case of truncation, it's still going to be 7.23. So make sure you really know the difference between rounding and truncating. When we round, if the number is 5 and above, we round up. If, however, we have, say, for instance, 7.24, and we were to round this to one decimal place, because of this 4 or any number below 5, we round off. So this to one decimal place will be 7.2. So please, please, please make sure you know the difference between truncating and rounding. In the case here, if we were to truncate to one decimal place, the answer would still be 7.2. So sometimes when you truncate and round to a certain degree of accuracy, you can end up with the same answer. All right. Now, in the context of truncation, we need to have a good understanding of error intervals because usually questions involving truncation will be related to error intervals. Now, I'll start with this example here. So let's think about Michael Jordan's height as being 198 centimeters to the nearest centimeter. So what that means is that Michael Jordan could potentially be 197.5 centimeters tall. He could also be 197.6 centimeters tall. He could also be 197.7 centimeters long, because all of these numbers to the nearest centimeter would round to 198. Likewise, he could also be 198.4 centimeters tall. And again, this to the nearest centimeter would round to 198. So there is actually a range of heights which Michael Jordan could be. And if we were to think about the degree of accuracy, this is where error intervals and bounds would come. So in the case of Michael Jordan, if we were to draw a little scale here, let's say if to the nearest centimeter, he's 198 centimeters, 1 centimeter down is 197, 1 centimeter up is 199. So the range of heights which Michael Jordan would be to the nearest centimeter would be 197.5 all the way up to, but not including, 198.5. And this is how we would write the error interval. So for instance, Michael Jordan could be 197.6, could also be 198.4 centimeters. So any value within this range could be Michael Jordan's height. So we would write the lower bound, which is 197.5, is less than or equal to, let's say, h for Michael Jordan's height. And then h is less than 198.5. So in essence, what this means is that Michael Jordan's height is 197.5 all the way up to, but not including, 198.5. And this is what we would call the lower bound. So the lowest possible height to the nearest centimeter, and this is the upper bound. So anything below the upper bound could be Michael Jordan's height. And if you wanted a definition, this is how we would define the upper and lower bound. So just something for you to have a read of if you want to pause the video. So let's do some examples then. Here's a question. It says, the height h of a plant was given as 53.1 centimeters truncated to 1 decimal place. State the error interval. So what we need to find is the upper and lower bound. Now, truncated to 53.1 centimeters. So the height of the plant could have been 53.10. We can truncate this to 1 decimal place and we'll get 53.1. The height could have been 53.11. Again, if we truncate this number, we would get 53.1. It could have been 53.12. Could have been 53.13. It could have been 53.14. It could have been 53.1479. Could have been 53.19. It could have been 53.19999. All of these numbers would truncate to 1 decimal place as 53.1. And the smallest possible value, our lower bound, would therefore be 53.1 or 53.10. So the height of the plant is greater than or equal to 53.1. Hence why we write the less than or equal to sign here. This is the standard format in which we write error intervals. And the maximum possible height would be 53.1999. It can't, however, be 53.20 because this number truncated to 1 decimal place would be 53.2. So the upper bound in this case would be 53.2. So the range of heights for the plant could be anything between 53.1 all the way up to 53.2, but not including 53.2. And this is our error interval to 1 decimal place. Let's try another question then. Now it says the distance D was given as 6.73 meters truncated to 2 decimal places, completely error interval for the distance D. So again, what is the lowest possible value that we could have had for the distance? Well, we could have had 6.730 as this would truncate to 6.73 to 2 decimal places. Could have had 6.731. We could have had 6.732. Could have had 6.73333. We could have had 6.739. And we could have had 6.739999 recurrent, and so on. All of these numbers again to 2 decimal places. So if we were to truncate them and get rid of the 3rd decimal, all of these would truncate to 6.73. Now, the smallest possible value that truncates to 6.73 is 6.730. So our lower bound is 6.73, which is less than or equal to the distance. And our upper bound, well, the next number that would round to the next value, so 6.74, would be, in fact, 6.740, as this number truncated to 2 decimal places would round to 6.74. Therefore, our upper bound is 6.74. So once again, the distance in this case could have been anything between 6.73 all the way up to 6.74, but not including 6.74. Hence why we write less than and not less than and equal to. So if you were to write your error interval like this, that would be incorrect. All right, so let's try another example. So it says a length L was truncated to 2 decimal places and is now 0.94. Which of the following is the correct error interval for L? So what is our lower bound? So our lower bound could have been 0.940. This would truncate to 2 decimal places. It could have been 0.041111. This again would truncate to 2 decimal places as 0.94. Could have been 0.9499999. This would again truncate to 0.4. So our lower bound in this case would be this number here, 0.940. So our lower bound could be A, it could be C, and it could be D. What about our upper bound then? Well, the highest possible value we could have is 0.94999 recurrent. The next number will be 0.95, and this does not truncate to 2dp to 0.94. So this is our upper bound. This is the maximum, or 0.94999 is the maximum value we could have, but this is how we would write the upper bound. So our upper bound could be C, so it's not going to be A anymore, but it can be C and it can be D. Both of these, the bounds are correct. However, what about the notation then? So can the length be equal to 0.94? Well, here we established that it can be. So this is the correct notation because the length is greater than or equal to 0.94. So once again, as we write our bound, the length is anything between, including 0.94, all the way up to 0.95, but not including 0.95 itself. So C would be the correct answer here. All right, let's try one more example. So it says, Tiago has chosen one of the numbers from the list below. Can you use the clues to work out which number he chose? So this involves rounding to significant figures, rounding to decimal places, and truncating. So well, we round, and we truncate, and in this case, it will be to 1 decimal place as well. So the first clue, it says, when rounded to 1 significant figure, Tiago's number is 3. So 2 is our first significant figure, so we have to look at the second significant figure, and this will round to 3 to 1 SF. Likewise here, this would round to 3 to 1 SF. Likewise here, this would round to 3 to 1 SF. Likewise here, this would round to 3 to 1 significant figure, as would this. This here, this would round to 4 to 1 significant figure. So this is not going to be one of our options. Clue 2, when rounded to 1 decimal place, Tiago's number is 2.6. Well, this number here, rounded to 1 decimal place, this is going to be 2.7. So this 8 will mean our 6 will round up to 7. So it can't be this. It can be this. So 2.50 will round to 1. Actually, it says it will round to 2.6. So it can't be this either. This number will round to 2.5. This number here, 2.63, does round to 2.6 to 1 decimal place. This number here as well, 2.56 to 1 decimal place. Again, this 5 here will round up because of the 6. And lastly, over here, we have 2.52. Well, this will round to 2.5 because of the 2. So this is not going to be it either. So we're left with 2 choices, and it says when truncated to 1 decimal place, Tiago's number is 2.5. So if we were to truncate these 2, in other words, get rid of the second decimal, Well, this number truncates to 2.5, this number truncates to 2.6, so it can't be this one. So our final answer is going to be this one over here. So 2.5 satisfies all conditions. Right, so this brings us to the end of our lesson. Please make sure you know the difference between rounding to decimal places and truncating to decimal places. That's critical, especially when writing your error intervals. And when you do write your error intervals, it's usually in the form of the upper bound is less than or equal to whatever value you're working with. So we'll call it x, and x is less than the, oh, and I've made a mistake here. This should be the lower bound. And x is less than the upper bound. Right, I hope you found this useful, and I look forward to seeing you again. Thank you. Bye.